Today we're going to be looking at functions. Specifically, we're going to talk about subsets of functions and real numbers and identify and evaluate functions and state their domain. Some key vocabulary that might not be totally familiar. When you see set builder notation, that just talks about when you write domain in forms such as this. Maybe that -5 is less than or equal to x, which is less than 7. Something in that form would be set builder. Interval notation would be if I wrote it in this form, where I used a bracket to say -5 and then put the comma and put 7 and a parenthesis on this side. That would be interval notation. Both of those mean the same thing. Remember, a function means that each x has a unique and only one y value. When I say unique, that might not be the best word. That each of x only has one and only one y is a better way of thinking about it. Each x only has one y. Let me think, what else? Independent variable, this is your x. Dependent variable is your y, also known as input, output, or this would create the domain. This would also create the range. And piecewise would be like multiple functions working together. That'll be multiple functions working together. We'll see that here in a little bit. Some subsets. So real numbers contain anything that you know of that you would ever see and say, oh, that's a number, then it would be real. Okay, so what this does is it shows you what all numbers belong to. So when you first learn how to count, you're learning about these that we call the naturals. They'd be the numbers 1, 2, 3, 4. Little kids don't know the number 0, but they do know 1, 2, 3, 4. That's the natural numbers. Those are the smallest subsets. Now, after the naturals, you have the wholes. And really, all this does is it includes 0. So if this was 1, 2, 3, so on and so forth, this would just start with 0 as well. Nothing different. Here, this z stands for integers. These are any whole number, but could also be negative whole numbers. So here we have not only 0, 1, 2, and 3, we also have like -1, -2, plus 0, plus those over here. Finally, this Q stands for rationals. That's anything that can be written as a ratio, okay? So here are some examples there, but I'll just put 1/2. That would be 1, -3/4. Anything that can be written as a ratio. Okay, I is irrational, so things that cannot be written truly as a ratio. These are where a lot of the square roots would be. So like the square root of 5 is not a nice number. Anything such as that would be irrational. So let's first look at using set builder. What is the domain using set builder notation? Okay, so here the smallest number we see is 2. The largest number is 7, so it would span. We would say that 2, if we're going to use the value x, is less than or equal to x, which is less than or equal to 7. However, we cannot be decimals or anything like that. These are just counting numbers. So as long as x is a member, and the way you do that is this e, it means an element of. And these could be the natural numbers, so we could do that in like they did before, or you could have chosen the whole numbers or integers. But since these are counting numbers, I'll just do x is an element of the natural numbers. I could not say reals with the r because, again, like some number like 2.5 would not work here. Okay. Here it is. X is greater than -17. Now, what we could also do is -17 is less than x, which is less than infinity. That would tell you it goes on forever. Since this does not tell us that x cannot be a decimal or anything like that, what we would then say is that x is an element of the reals. So that means that x could be 16.233333 or something like that. And finally, describe all multiples of 7 using set builder notation. This would be like numbers like 7, 14, 21, numbers like that. Okay, so to get values like that, we would say that x is going to equal 7 times some number. Here's the deal. That number needs to be now these could also be negative. So it could be, we need to multiply it by whole numbers, but they could also be negative. So the ones that were whole but could be negative, if you remember, is Z. That symbol Z is like a double looking Z. The reason it's Z is because it could be positive or negative. Okay, so all of those are multiples. And also the reason we use n is because n is the one that's really doing the work to create x. So we would just start with n.